All right, moving into week 3 with section 1.6, which is going to get us some concepts of solving other types of equations, particularly radical equations and absolute value equations. And so we're also going to kind of get into some higher order polynomials as well. So that's what we're going to start with, and we're going to go back to the idea of factoring to help us out in solving these higher ordered polynomials. Now I will tell you that first off, we need to remember to get our equation equal to 0. So I may want to underline this right here for you. And then factor out any common terms before factoring with special cases, grouping, or with trial and error. So let's look at this equation here. And whenever I want to get this equal to 0, I need to bring over this 12x squared by subtracting that from both sides. Remember, what you do to one side, you do to the other, and you have to do the opposite. So when I do that, I end up with a 4x to the 4th minus a 12x squared, and then we have our equal to 0. And this is where we want to factor out anything that is in common. And so notice there is a common 4 with our numbers, and there's a common x squared. Remember, that lowest power is what we want to take out first. So we want to take out a 4 and an x squared, and then I have to determine what I'm left over with. And so 4x squared times what gives me 4x to the 4th? Well, there are 2x squareds that are missing. Minus 4x squared times what gives me 12x squared. And so I need a 3 to go with the 4 to make a 12, and I already have that x squared out. So that only needs to have a 3. Now, just like when we were solving equations, when we were factoring earlier, then we have to set each of these factors equal to 0 and solve. It's just that now, notice that the highest power or the degree of our equation is a 4. That's going to indicate how many roots that I get, or how many answers that I get. So I'm going to set that 4x squared equal to 0, and I'm going to set the x squared minus 3 equal to 0. Before we kind of did that shortcut, if we had a power of 1 here, we asked ourselves what minus something gives us 0, but I would recommend kind of breaking them apart here. So if I want to solve that 4x squared equals to 0, I'm going to divide both sides by 4 to get my x squared by itself. And 0 divided by 4 is 0. And when I want to undo a square, don't forget that operation is to square root both sides. And don't forget, we always have that plus or minus here on this right side. Square cancels out the square root, leaves me with an x. Square root of 0 is 0, and 0 is not signed. So I'm just going to give a 0 here. Now, what that really technically tells me is that this is a double root. I'm going to put dr there for a double root. It basically occurs twice. If I need 4 total, there's 2 of them right there in disguise. I'm going to add 3 on this equation because we need to find our other 2. This becomes 0, so I'm left with x squared on the left equals a 3. And again, just like last time, I'm going to square root both sides. Don't forget your plus or minus. That square cancels the square root, leaves me with an x. And then the best I can write this is plus or minus the square root of 3. And that's by using that square root property that we have. So there's 2 answers, and here's the other 2 again in disguise. If we write it in a set notation, it would look something like this, 0 and then plus or minus root 3. So those would be my answers. All right, let's try this 4-term polynomial. Again, we need it equal to 0, so I'm going to end up subtracting over some terms. I'm going to keep that positive highest power, and I'm going to subtract each one of those over. So what I get is a 2x cubed plus a 3x squared, just rewrite those, minus an 8x minus a 12 equals 0. Okay? Now, I set up here, get it equal to 0, take out any common terms before factoring with special cases or grouping. This, if you recall, is one of these grouping problems that I need to group 2 by 2. So I'm going to group those 2 and those 2 together. So let's review that. Of these 2, I'm going to take out what's common. Notice there is an x squared common to both. No numbers are common with 2 and 3, so I'm going to take out an x squared. And I'm going to determine that I need a 2 and another x to make the 2x cubed. I took away the x squared, so I need a plus 3. And notice on these two terms, both of them have a negative, so let's go ahead and take out that negative. And between 8 and 12, what's the least common, or the common factor, or the greatest common factor, I guess you could say, between 8 and 12? That number is a 4. So I'm going to take out a 4. So negative 4 times what is negative 8x? Well, I need a 2 and an x. If I take that negative out, it becomes positive. And so what do I have here? 4 times what gives me a 12? It is a 3, equal to 0. Now, hopefully this is going to also kind of make sure that you derive what happens here. These need to be the same in a case like this, because now with these two terms, there is a common expression here as a 2x plus 3. And I'm left with, if I factor that out, what's in front of each of those. So I'm left with an x squared minus a 4. So this is back in section P.5 when we were factoring. So if you need to review that, please do so. All right, so this is as far as I can go down, but the question would be, can I go further with this? And the answer is yes. It is one of those difference of squares. So that a squared, you need to remember a squared minus b squared was equal to a plus b times an a minus b. So they're exactly the same except for one's a plus and one's a minus. So I need to split up the x squared as an x and an x. And what do I square to get a 4? That is a 2 and a 2. So all of that is still equal to 0. So you want to make sure, again, you factor all of it down as far as you can. Now here is the case where we go through and we say, what makes each one of these zeros? We can do that with the nice power of 1. Over here, not so much with the power of 2. It's a little bit more difficult. All right, with this 2x plus 3, again, you can set it equal to 0 just like what we did over here. But the shortcut, if you remember, taking the opposite of this over 2. So negative 3 halves, and that's what you should get if you set it equal to 0. What number plus 2 is 0? That would be a minus 2. And what number minus 2 is 0? That would end up being a positive 2. Therefore, these three answers are my solution to the equation. Notice here the highest power is a 3. That means I need 3 answers, which I do. Okay? All right. And our last one here looks very similar to our first one, except we don't have an x squared here. So I'm going to go ahead and subtract this over. Change colors here. Okay, so when I subtract that over, I get a 3x to the 4th minus an 81x equal to 0. Now, we want to make sure that we take out any common terms. Between 3 and 81, there is a 3 in common. And between x and x to the 4th, we do want to take out the lowest power, so it will be an x. Now, what's left over? 3x times what is 3x to the 4th? Well, I need 3 more x's, so I need an x cubed. Minus 3 times a 27, if you do 81 divided by 3, gives me 81. So 3 times 27, and I already brought out the x. Now again, just like over here, can I go further with this? I can't go further with this one, but I can go further with this. Hopefully you recognize this is one of those special cases as a difference of 2 perfect cubes. So I'm going to factor that, go back to section P.5 if you forget that this factors to a binomial times a trinomial. Squeeze in my equal to 0. We have to remember SOAP, so it's going to be the same, the opposite, and always positive. What do we cube to get an x cubed? It is an x. What do we cube to get a 27? It is a 3. Then our pattern for this next part, if you recall, is to square the first, multiply the 2 together, and square the last, which gives me a 9. Okay? Now, it is true that this trinomial here will never break down, but we can actually find the roots that make that true. So for instance, these two aren't too bad. What number times 3 is 0? Well, that kicks out x equaling 0. What number minus 3 gives me 0? Well, that's x equals 3. Okay, and again, you can set them equal to 0 just like what we did over here if you want to. Now this one is not so nice, okay, because we can't factor it, but I can find the roots. The way that we did that was, if you recall in the previous section, we can do it by factoring the square root property, completing the square, or most recently the quadratic formula. So I'm going to go ahead and use the quadratic formula on this to figure out what their actual roots are. Okay, so I'm going to squeeze that in right here. So this is where we were singing, if you wanted to sing, x equals negative b plus or minus the square root of b squared, which is a 9, minus 4 times a, which is a 1, times c. So 4, for space purposes, I'm putting that up here. 4 times a times c is going to be a 36. Now that's a positive 36. All over 2a, which is a is 1, so 2a is going to be a 2. All right, so what do I get when I clean that up a little bit? That gives me negative 3 plus or minus 9 minus 36 is a minus 27 all over a 2. And I do believe that 27 can break down as a square root. First off, it's going to be an I that's going to come out of there because of the negative. So we're going to bring that out and make that an I. But if I break 27 as 9 times 3, that's going to get me my radical simplified. So negative 3 plus or minus square root of 9 is 3. Don't forget the I that comes out with the negative. Square root of this 3 is left over, all over a 2. So negative 3 plus or minus 3i root 3, that's a 3, all over 2 will be my final answer. Okay, so those are two answers. Those are imaginary answers. Here are my other two. So if we need to kind of list them out, you want to make sure you list all of those. What's the highest power? It is a 4. So I needed 4 answers there, which I got. Okay, all right, very good. So that's some higher order polynomial equations for you by factoring. So factoring is so important. We aren't going to go away from that for very soon, so you need to make sure you can do that. All right, let's talk about radical equations. Radical equations aren't too bad. We have to do the opposite of what we are doing with when we are squaring, or when we're square rooting. So the opposite of that is going to be squaring. So remember that those are inverses. So by definition, a radical equation is an equation in which the variable occurs in a radical. So look down here. I have a variable in my radical. Here I have a variable in my radical. Those are radical equations. Here are the steps that I have for you to take in order to solve those radical equations. And there are 4. But I will tell you that the very last one is very, very important because when we start squaring both sides of these equations, there are some extra roots that pop up. And that's what we call the extraneous roots. So if you see the extra in the first, they just kind of pop up. And in order to figure out is it an actual root, we have to go back and plug it into our original equation, okay? So I'm going to scroll down a little bit. We're going to do these steps by example with our first one here. It says we're going to first isolate the radical on one side by itself and everything else on the other side. There will be times when you have multiple radicals. You want to make sure you have one radical on both sides. That's going to be the easiest, okay? But for our first one, that radical is on the one side by itself. Everything else is on the other side. The second thing we're going to do is get rid of that radical. So to undo a square root, I must square both sides. Remember, they are inverses of each other. So what I do to one side, I must also do to the other. And this square will cancel out that square root, basically. And we're left with whatever's left over, the radicand, underneath. On this side, tells me that I'm going to get an x squared. And now we have an equation that we can use all of our other tools to solve. Now, this is a quadratic equation with a power of 2. It is nice and positive, so in order to solve that, I need it equal to 0. So I'm going to bring over these two sides. To keep this one positive, I'm going to add the 8x, and I'm going to subtract the 20. So I get x squared. Adding 8x gives me a plus 8x, and then subtracting 20 gives me a minus 20. And then we have it equal to 0. Now, here's where, again, our factoring comes into play. This is a trinomial, nothing in common, so it goes down into 2 binomials. And since our last sign is a minus, they are different inside. I'm going to split up my x squared as x and x, And since we have a 1 in front, we can ask ourselves, what do we multiply to get 20 that I subtract to get 8? Well, we have 1 and 20. When I subtract, I get 19. 2 and 10. When I subtract, I get 8. Oh, ding, ding, ding. That's the one I want. So I need a plus 8. So in order to get a plus 8, when I'm subtracting these, I need a positive 10 minus a 2. So I need the 10 to go here and the 2 to go there. Now again, you can always double check that, remember. Foil that to see if you get back what you started with right here. If you do, you did it right. If you don't, then you need to go back to the drawing board and figure out what factors work. Alright, so what makes this guy 0? What number plus 10 is 0? I'm hoping you're screaming at me negative 10. What number minus 2 is 0? And that answer is 2. Now these are our possible solutions. We have to now throw them back in to double check to make sure that that works inside my original equation. So you can just do a little small check over here if you want. If I do 20 minus 8 times a negative 10, is that equal to, throwing negative 10 in for x, is that equal to negative 10? That's the question. These two negatives become a positive, and this becomes an 80. So this actually becomes down to 20 plus 80, which is actually 100. And is the square root of 100 equal to a negative 10? Nope. Hope you're shaking your head. It is not. Therefore, that is not a root. That was one of those extra roots that come into play. If I throw 2 in there, if I do the square root of 20 minus 8 times 2, is that equal to 2 when I throw in 2 into that x? So this gives me 16. 20 minus 16 gives me a 4. Is square root of 4 equal to 2? Most definitely it is. So that is the only answer that works in that case. Okay? All right, very good. Let's look at this next equation. I have a radical on one side, but it's not by itself, so I need to get that by itself. Now, there's lots of ways to do that. You can subtract the x over, but then you have a negative in front of that radical, which normally we don't like to see. So here's my suggestion. I'm going to try to add that whole radical term over here so I can make it positive, and then I'm going to subtract the 1 over here so that I can have just a radical on the right side. So again, subtract over the 1, that gives me an x minus 1. And when I add over that radical, that gives me a positive x plus 11 on the radical. Okay? All right, so 1 is done. I've isolated the radical and everything else on the other side. Number 2, we're going to square both sides. So I need to square all of that. Here's where my mistakes happen. Students like to square individually here, and that is incorrect. You need to square the entire thing. Okay? All right, so when I do that, these are two terms that need to be foiled together. So if you want to cross this out and rewrite x minus 1 again and foil that, please do so. That gives me an x squared. Outside is a minus x, inside is a minus x, gives me a minus 2x. And my last term becomes a negative times a negative, which is a positive 1. And over on the right side, that's the easiest one. That square cancels that square root, leaves me with an x plus 11. Nothing under that changes. Okay? So now I need it equal to 0. So I'm going to, since my x squared's over here positive, I'm going to subtract the x, and I'm going to subtract the 11. So when I do that, when I subtract an x from negative 2x, I get a minus 3x. And 1 minus the 11 is a minus 10. And here we go with factoring. Again, that's why it's so important for you to know how to factor. Last sign is a minus, so they are different. I'm going to split up my x squared as an x and an x. And what do I multiply to get 10 that I subtract to get 3? Well, 1 times 10, 2 times 5, subtract 2 times 5, I get 3. Now I need a negative 3, so I need a minus 5 plus 2 gives me my factors. Again, foil this if you have to, just to double check that you get what you started with. So the question then is, what do I get whenever I add 2? What number plus 2 gives me 0? That's negative 2. What number minus 5 is 0? And that number is 5. So these are my possibilities. I must now put them back in the original problem to see if they work. Okay, so if I check, say, negative 2 minus a square root of negative 2 plus 11, is that equal to 1? Well, this gives me a 9. So the square root of 9 is 3, so I get negative 2 minus 3. Is that equal to 1? Absolutely not. So that's not going to work. When I throw 5 in there, if I do 5 minus the square root of 5 plus 11, is that equal to 1? Well, this gives me 16, so this is actually a 4. And when I do 5 minus 4, that does equal 1. So that would be my only solution. Now, I will tell you that if that didn't work, then don't forget, if nothing works, empty set is going to be your answer. Okay, but in this case, there is one that actually works. Okay? All right, very good. Let's check out this last problem. This last problem, we're going to kind of move into probably this other side, or if you want to write small, we'll be able to kind of work it out as well. Well, let's start with that. Okay, so I need to isolate one radical by itself on either side. So in this case, I'm going to go ahead and move this over to the other side, leaving me with the square root of x plus 5 equals 2 plus the square root of x minus 3. Okay. Now, step 2 is that I square both sides. So I'm going to square the left side, and I'm going to square all of the right side. Now, on the left side, this square is going to cancel that square root. We're left with our x plus 5. And on the right side, this is where it's going to get a little bit tricky. If you don't know that pattern with that quantity square, we can still FOIL this, but it's going to look a little bit strange this time. Okay, so if I do my first terms, that gives me a 4. The outside is going to be 2 times that radical, and the inside is also going to be 2 times that radical. So 2 radical x minus 3 plus 2 radical x minus 3 is going to be 4 times the square root of x minus 3. And then my last terms, I'm going to square that square root. So just like whenever I did like the square root of 3 times the square root of 3, that's 3. Square root of 2 times square root of 2 is 2. This square root times that square root is just going to yield what's underneath there. Okay? All right, very good. So now we got to clean all that mess up. So first thing I'm going to do, I got to get this to the other side. Actually, no, sorry. We still have a radical inside there. So what I want to do is isolate that radical, get it by itself. So all of this stuff over here needs to come over to the other side. So let's subtract x. And that's really nice because those actually go away. And then I have this plus 3, a minus 3 and a positive 4. So if I combine these two things here, is everybody okay with that being a plus 1? So then I would actually subtract 1 from both sides. So this ends up with a negative 4 equal to, all of those now go away, equals to 4 times that square root of x minus 3. Okay. Now, we still don't have the radical all by itself because I have a 4 times that. So if I want to undo that 4 with the times, I'm going to divide both sides by 4, which is easily done. If this wouldn't be nice here, I would recommend not to do that, but here you can. Okay, so let's kind of bring this over here. On the left side, negative 4 divided by 4 is a negative 1. On the right side, I'm just left with that square root of x minus 3. Now again, we're back to kind of step 1 where we have to kind of isolate that radical. Then we're coming back to square both sides because I'm not done yet. I don't have x by itself, so I have to keep going as many times through those steps as needed to get the radical gone. So this is equal to a 1, and this square cancels that square root, leaves me an x minus 3. And so then I'm going to solve for x by adding 3 and adding 3. Therefore, x equals 4. Now, that's the only answer that's kicking out. But again, we have to double check to make sure that that works. If I throw 4 back in here, that gives me a 4 plus 5, which is the square root of 9. Then if I put 4 in here, I get 4 minus 3. That gives me a square root of 1. I need to subtract those two to equal a 2. And does that work? Well, this gives me a 3. This gives me a 1. Definitely those do subtract to give me a 2. So that is the answer that works. Now remember, if that did not work, then your answer would be the empty set because there is no answers that would hold true for that as well. Okay? All right, very good. Let's do our last type of equation. Get in some absolute value equations. And there is a common mistake that happens with these. So students forget that you have to have 2 answers with these. And so, as a reminder, the absolute value of a number x is defined to be the distance from 0. Given an equation, like say the absolute value of x equals 5, which would constitute an absolute value equation, there are 2 numbers which will satisfy that equation. So what number can I throw in for x, then take the absolute value to equal 5? Well, I hope you're saying that 5 is one of those possibilities. But we can't forget about the other side of 0 when we talk about distance to be positive. And so, -5 will actually also be an answer as well. Okay, so make sure you remember there are 2 answers that work there, a positive and a negative of what's inside there. Okay, therefore, here's what we need to do when we create an absolute value equation. And I'm just going to kind of do this in generic terms. And I like to do it this way because it's so important to know that what's inside those absolute values does not change until you start solving them after you split them up. So if I have an absolute value of something, an absolute value of star is equal to A, there are 2 equations that you have to set up and then solve to find the 2 answers. It's not always going to be a number and its opposite. It could be 3 and -3, or excuse me, 3 and -10 or something like that as answers. And so you want to make sure that you solve after you split up. So we're going to rewrite this exactly as it stands, except with that absolute value. That's going to be one equation. So star is equal to A. Or I'm going to rewrite this equation with without the absolute value. So I'm going to have star is equal to the opposite of that A. And that goes back to kind of this idea where a number and its opposite is going to work for that. So if this in here is that opposite number, then the absolute value of that will also kick out A. So we're going to use that idea in order to solve these 2 equations. Now, the thing about it is you must have your absolute value by itself. The first 2 have that. The next 2 do not. So we can use some algebra to fix that right up. All right, if the absolute value is by itself, we are going to split it into 2 separate equations. The first equation comes from rewriting this as is without the absolute value. X plus 2 equals 6. Throw away the absolute values and write it down. Or I can write whatever's inside here, whatever that is, can also equal -6, so that when I take the absolute value of that, that is going to equal the +6 that I need. Once you have these 2 equations, you are ready, set to solve. So I'm going to subtract 2 from both sides. And this goes away. X here is equal to 4 on this one. Or this one goes away here. X is equal to -8 on that one. So here's my 2 answers, 4 or -8. Same idea. Absolute value by itself, I'm going to split it into 2 equations. The only difference is this is going to take a little bit more to solve because I got more numbers in there. So I'm going to rewrite exactly as is without the absolute value. Then I'm going to rewrite exactly what's inside there. Do not change this. That has to equal to the opposite of this number, which is -11. And this is where your 2 numbers are going to change, okay? I'm going to add 3 to both sides. Let's just solve the left one by itself first. This gives me 2x is equal to 11 plus 3 is 14. Then we're going to divide by the number next to the letter. Therefore, x equals 7. Whoops, I forgot my or. Or, what's the other one? I'm going to do the exact same process of adding 3 and dividing by 2, but because that's a -11, I'm going to get a different answer. 2x is equal to -11 plus 3. I owe you 11 bucks and I pay you 3. I still owe you 8. Then I'm going to divide by the number next to the letter. Therefore, x equals -4. These are my 2 answers to solve that absolute value equation. Okay? All right, now here are the 2 things that you want to make sure that you remember. The absolute value expression needs to be by itself before it can be solved. And I always like to make sure it's on the left side for whatever reason, Guess that's what I'm just used to. And then a no solution answer will result when the absolute value expression is equal to a negative number. So we'll see that in just a second. Okay, let's first solve this guy. Absolute value is not by itself. So if I want to get this all by itself, this is just like if I had 4y plus 7 equals 10. How would I get y by itself? Well, I have to get rid of that 7 first. So over here, I'm going to subtract 7 from both sides. I'm left with 4 times that absolute value of 3/4 x is equal to 10 minus 7, which is 3. And then I'm going to get rid of the 4 that's in front, timesing by that absolute value. If that's a times, to undo that, let's divide by 4. That is the opposite. That goes away. And I'm left with the absolute value of 1 minus 3/4 x is equal to 3/4. And now is the only time that we are allowed to split up that absolute value. I have two equations that I need to write, one being exactly as is without the absolute value bars. So I get 1 minus 3/4 x equals 3/4. Or I'm going to rewrite what's inside there. And I'm going to set that equal to the opposite of this a value out front, which is negative 3/4. Now, this one might look a little bit nastier because it does have some fractions in it, but don't panic. We can get rid of those fractions by multiplying by what's in the denominator. So in that case, the common denominator is a 4. Notice that in each one of these fraction ones, they cancel. 4 times 1 is a 4, minus, don't forget that 3 with that x, so we have a 3x. Is equal to a 3, and I can subtract 4 from both sides to get x by itself, and I get negative 3x is equal to 3 minus 4 is negative 1. Divide by negative 3. Go ahead and simplify those two negatives, make a positive, so the best I can write is 1/3. Or, what's our other answer? The process to solve is exactly the same, so I'm going to times by 4 each time. Those cancel, times by 4. And again, this is exactly the same, except for now we get a different number over here, which is negative 3 this time. Let's subtract 4 from both sides. Again, the process is exactly the same. Gives me a negative 7 when I do negative 3 minus 4. And I'm going to divide by negative 3. Now remember, 3 and 7 can't be reduced, but I can go ahead and change those double negatives to a positive, and I'm just going to write that as 7/3. So 1/3 and 7/3 are my answers for this absolute value equation. Most often than not, your numbers will be different. They won't be their opposites of each other, okay? So make sure that you don't get set into that. All right, let's try this guy. If I'm going to get this absolute value by itself, I'm going to subtract 12 and subtract 12, and I get the 2 times the absolute value of an x plus 3 is equal to 4 minus 12 is actually a negative 8. I can go one step further and divide by that 2, divide by that 2, and I get x plus 3 in absolute value is equal to a negative 4. Now this, a lot of times we'll get used to the process and we'll just go ahead and start splitting them up into two separate equations, but actually you want to kind of step back and look outside the box a little bit and decide this absolute value has to be positive. So for it to be equal to a negative does not make sense. Empty set's going to be your answer here. And so you always want to watch that when you have those absolute values. Make sure that it's equal to a positive number. So it can never be negative. All right, very good. So in this unit, we've looked at radical equations. We looked at solving higher order polynomial equations by factoring. Make sure that you factor all the way down. And we've thrown in these absolute value equations as well. So a lot thrown at you in this section. Keep at it. You guys are doing awesome. Until next time.